Hello, welcome everyone. As you start trickling in, we'll get started in just about a minute. We'll just wait until everyone's able to join into our workshop this evening. Okay, so we're steadily growing here with our participants. Hello and welcome everyone to our Fall Open House 2022 virtual session, Preparing for the Canadian Senior Math Contest, CSMC. My name is Laura Jane Watkins. My pronouns are she and her, and I am the undergrad recruitment coordinator for the Faculty of Mathematics. I'm excited to be introducing our host for today's session, Professor Ian VanderBurgh, the director of the Center for Education in Mathematics and Computing, CEMC. Before we hand things over to Ian today for your workshop, I'm happy to share with you a short overview of what the CEMC is, how they are affiliated with the Faculty of Mathematics, and why you might want to take part in their fantastic contests as part of the application process to our undergraduate programs in the Faculty of Mathematics at the University of Waterloo. The CEMC is dedicated to inspiring students to reach further with mathematics and computer science. They're committed to giving students the tools they need to build their confidence, grow their problem-solving skills, and get excited about mathematics and computing. They bring over 50 years of experience to the work they do. Their story began in 1963 when a group of secondary school teachers developed the first mathematics contest in Ontario. From that spark, the CEMC has grown into one of Canada's foremost authorities on mathematics and computer science for young people. Housed within the Faculty of Mathematics at the University of Waterloo, the CEMC is the largest organization of its kind in Canada, with more than 40 dedicated faculty and staff and hundreds of committed volunteers. Today, their programs and resources make a difference for students and educators around the world. Their free courseware receives 10 million page views annually. More than 265,000 students in over 80 countries register for their 15 contests each year. 1.5 million learners and teachers benefit from their problem of the week. 630 learners participate in the CEMC workshops annually. 20,000 students benefit each year from the CEMC Visit Schools program at more than 300 schools in over 15 countries. And 300 teachers are currently pursuing advanced degrees in their Master of Mathematics for Teachers, MMT program. And hundreds of MMT alumni are sharing new knowledge and renewed enthusiasm with their students around the world. So while it is not a requirement that students applying to the Faculty of Mathematics participate in these contests, we highly recommend that all applicants participate in the Euclid or the Canadian Senior Math Contest. If a student performs well on a contest, it can certainly be a favorable addition to their application. In contrast, if a student performs poorly on a contest, it will not negatively affect their chances of admission. We encourage students to challenge themselves by participating in contests and would not penalize them for doing so. Students are welcome to write both contests if they wish. However, if they choose to write only one, the Euclid and the CSMC are considered equally. It is important to note that participation in the Euclid and our Canadian Senior Math Contest is a mandatory component for consideration for some of the Faculty of Mathematics entrance scholarships. So thank you for listening to this introduction, and please feel free throughout this session to submit any admissions related questions through the Q&A today, where we have team members from our undergrad admissions team ready to answer any questions that you may have. So welcome, Ian VanderBurgh, and thank you for presenting this information to our group today.
Thank you, Laura Jane, and good evening from Waterloo. It's great to be here with more than 220 very keen and excited people to do some mathematics here on an evening in Waterloo. Before we get started, I would love it if you would find both the chat and the Q&A and go into the chat if you feel comfortable. Tell us where you're joining from this evening. Halifax, Toronto, Whitby, Brampton, Toronto. Lots of people from all, wow, this is going fast. This is very cool. Thank you, everybody. Vancouver, Waterloo, Mississauga, Cambridge, Nova Scotia, South Bruce, Edmonton, Vancouver, Vaughan, Dresden. Very nice. Thank you, everybody, for sharing. It's great to have people hear from, just very quick, at a quick look from certainly across Canada, from people all the way, at least that I saw in passing, from Halifax all the way to Vancouver, and probably some more in other places. I'm just going to scroll. Manitoba, lots from Southern Ontario. This is great. Calgary. Well, we've got a great national coverage tonight. It's Montreal. So good to see so many of you. Thank you for being here. Thank you for taking some of your evening to talk about, to do some mathematics and to talk about the CSMC. As Laura Jane mentioned, my name is Ian VanderBurgh, and I'm the director of the CEMC and a faculty member here at UW. And I am really excited to be here to do some mathematics with you this evening. And I'm going to dive into that. I see already a few questions in the Q&A about the CSMC, and I'm going to try to answer some of those as I go along here. I'm going to spend about 8 or 9 minutes talking about the CSMC in general, and then we will get into doing some mathematics and talking about how you prepare and how to best write a contest like the CSMC. So I'm going to attempt to share my screen. Oh, no, not that. Over here, share screen. I've got two devices here, so you'll see me looking this way and that as I get ready, and I'm on the air there, and I am there, and that. I talk to myself as I share my screen always, and we're perfect. All right. Where did my Q&A go? Make sure I get the Q&A up. All right, here we go. So as Laura Jane mentioned, the CSMC is the Canadian Senior Mathematics Contest. It's written on Wednesday, the 16th of November in North and South America, and on Thursday, the 17th of November outside of North and South America. It's 2 hours long. Some of the questions are short answers, some are full solutions, 60 total marks, and the average is normally between 30 and 35. I'm going to come back to this in a minute. Some calculating devices are allowed, and it's written in schools. There have already been a couple questions about participating if your school doesn't participate. We are now past the registration deadline. So at this point, it's unlikely probably that you can actually get to write the Euclid unless you're in a school, the CSMC, sorry, unless you're in a school that's participating. The difference between the CSMC and Euclid, there's a slight difference in style of the contests, but generally speaking, they are very similar in terms of the content. One is written in November, the CSMC soon, and the Euclid in April, same idea. There are no programs that require taking these to get into Waterloo. There are no programs that you absolutely have to take this. As Laura Jane mentioned, we strongly encourage all of our applicants to do this for a couple of reasons. First of all, it helps demonstrate to us that you are interested in mathematics and computer science, and that's an important part of this. Second reason is by preparing for and writing a competition like the CSMC, you're going to learn a lot, and that will help you regardless of what field you go into. Whether you go into mathematics, computer science, another STEM program, writing, practicing for, preparing for, and writing something like the CSMC is an important kind of thing to do. This is the completely useless to you cover page for this year's CSMC. This is what it will look like when you sit down to write it. Unfortunately for you, I haven't included the questions behind the cover page, so you will not know what they are. But this is what the cover page looks like. I would strongly encourage you to make sure that you familiarize yourself with the CSMC, and I'll give you a couple of questions, a couple of things about this as we go along. The format. There are two parts. Part A has 6 problems. Part B has 3 problems. Each problem in Part A is worth 5. Each problem in Part B is worth 10. Part A, the questions are short answer, in that if you get the correct answer, you get 5 marks, full marks, with or without any work. I strongly encourage you to make sure you show some work when you're doing questions in Part A, and make sure you show it in an organized way. If you put some work and you have some things over here and then some things down there and some things over there, we're not going to be able to mark that and try to say, okay, well, I know what this person did, what their thinking was. As markers, and we will have a large crew of people marking the 13,000 CSMC papers that will be written, we need to be able to read and understand what you've written. And so laying out solutions, even if they're partial solutions to short answer questions, this is important. In Part B, when you're providing a full written solution, we will give you marks for correctness, as well as for style, presentation, clarity, and all of those kinds of things. Why should you write the CSMC? Well, for the challenge of it, this is an important part. Being challenged is a way that we grow, whether it's in mathematics, whether it's in a different discipline, whether it's as an athlete, whether it's as a musician. Challenge is what helps us grow. It's also fun. It should be fun, and to make sure you treat it like it's something fun rather than something that is really worrying or stressful. Go and have fun trying to solve some questions. That's really important. Also, in the end, most importantly, doing more math helps you get better at math. And doing more math that challenges you helps you get better at math. Sorry for the light behind my head. I'll try to keep my head from going too far from side to side and having that light blare through on you, for those of you who see my picture on the screen. How do you prepare for the CSMC? A few ways. Attend a preparation session. You can all check that one off the list. You're here tonight. That's great. Another way is to work through past contests. And I'm going to put in the Zoom chat here, link to past contests. There. So there's a link to the past contest page. There are about 11 years of past CSMC contests. And you can have a look at those and get a sense of the style, get a sense of the level of difficulty, get a sense of the topics. This is a great way to prepare and to have a good sense of what you're going to be thinking about. Doing this with other people is also really valuable, because as we problem solve together, we learn from each other. Tonight, we're not going to have that much of an opportunity to do a lot of back and forth, but we'll hopefully get some things going in the chat. We won't have time to look at multiple solutions generally, because we're only going to look at 4 or 5 problems. But when you work with your friends, maybe Laura Jane will have one way of doing it, and Pavak will have one day of doing it, and Amy will have one way of doing it, and I'll learn from them when we're sitting down to do math together. This is really important. Also, make sure you try problems before you read solutions. Reading a solution is a little bit like watching hockey on TV at a certain point. Oh yeah, I could skate like Sidney Crosby. Well, I can't skate like Sidney Crosby until I practice like that. Even then, I'm never going to skate like Sidney Crosby. Another good source for you is we have a newly revised set of Euclid and CSMC preparation materials, which I'm going to put a link to in the chat here. Again, there. And these are newly revised, and they look at different topics. So if you click on that link at some point, you'll see that there are 8 different topic areas. This is not to say that all of the questions on the Euclid or CSMC come from these topics, but it's to give you a sense of the kinds of things that you want to study. Pick one of these if you're looking at it, and try to and pick one where you think you could use some practice. If you think you're great at trigonometry, you don't need to look at the trigonometry. Look at the geometry one instead. The CSMC, like all of our contests, is marked by a group of trained people. We have solutions, we have marking schemes. We will be marking these in December. You should hopefully have your marks through your teacher, your scores, by the middle of December. And this is a really exciting part of our year, is to look and see the great work that all of you have done when you write the contest. Some tips. Prepare in advance. This is an important thing to do. Set your expectations too. I mentioned earlier that the average on the CSMC is usually between 30, 30 to 35 out of 60. If you think about that as a percentage, that's between like 50 and 60%. When we are really lucky here at Waterloo in that we have so many strong students interested in mathematics, interested in computer science, like all of you. And most of the students who are interested have generally getting marks in the 80s or the high 80s or the 90s. And then you write a contest and you get an average of among strong math students of 32 out of 60. This means that this is a contest, it's not a test. And so making sure you have a goal in mind, a reasonable goal. I think I can get 38 out of 60 on that. That would be a great thing to try to work towards. For some of you, it might be aiming for 30. For some of you, it might be aiming for 50. But have a sense of what that looks like to you. Make sure you start with problems that you know you can do. Read through the questions. Find something you say, yes, I think I can do that, and do it. Then go on to something else. Write better solutions to fewer problems rather than worse solutions to more problems. Try to slow yourself down a little bit. If you rush a lot, then you're going to not answer questions as well as you could. So take some time and write some better solutions. Read all of the problems at the beginning, write solutions, at least brief ones in part A, and make sure you try the early parts of all of the problems in part B. In part B, even the hardest question B3, will have early parts that are more straightforward to solve. And you'll see a couple of examples as we go along. Also worth knowing as well that question B1, there's 6 questions in part A, A1 through A6, 3 questions in part B, B1 through B3. These questions, B1 will likely be easier than A5 and A6. So if you find yourself getting stumped at A5 and A6, go over to B1. Does the order in which we write our answers matter? You will have a solution booklet in which to write this that we will provide to you, and it will have questions. It will have spots for each question. Make sure you answer the questions in the spot. If you have relevant work in part A for an incorrect answer, you will receive some part marks. And our marking scheme will tell the markers how to do that properly and consistently. There isn't a specific answer I can give you of how many part marks you get. It depends how close to an answer you get, how much progress you have made. So we're going to look at a small number of questions. As I said before, we're probably going to look at 5 or 6 questions. What I want you to do is read the question. Probably you're not going to have time to answer it fully. And I'm going to go quickly through a solution. Please understand that that's what I'm doing and that I'm not suggesting that this is how fast you should do something. Mathematics is not intended to be a speed sport. Mathematics is something that takes us time. And tonight I don't have time. I've only got 43 minutes left. So we're going to talk about some high-level strategies. I want you to understand those and not get too worried about some of the really technical details. And there will, of course, be lots of ways of doing some of the problems. Normally, if we were doing this together live, it would be easier to interact a little bit. We don't have that luxury here tonight. A couple of final questions, technical questions in the Q&A. Part B questions often have multiple parts, and each part has marks assigned to it. So if you get 3A or 2A and 2B or 1A, 1B, 1C, you will get part marks for those questions. You don't have to get the whole thing to get some marks. The distribution of marks between the parts depends a little bit on the parts, how much they are, how much work they are, how many parts there are, and all of those kinds of things. Let's dive into doing some mathematics here now. Here are 2 problems. I'm going to give you a couple of minutes to read these problems and think about them. What I want to highlight when I come back to this is the importance in mathematics of language and the importance in mathematics of notation. So take 2 minutes and read these questions. Pick one of them that you think you might want to try to start, knowing that we won't have a lot of time to do that. Give you a couple of minutes, I'll stop talking, read these and think about them briefly. So let's talk about these questions. I want to talk about each of them. We may get to an answer, we may not. And I hate to tell you, as a mathematician, it pains me to say this, I don't, in this case, care so much about the specific answer. What I really care about is the thinking. What I really care about is how we approach a problems like these. So while we may not get to the answer, we will talk a little bit about the thinking. So let's talk about the first one. This is number 1, and this one's number 2. Number 1 has an important mathematical word in, and that's the word consecutive. Can you type in the chat to see, tell me what you think the word consecutive means. Type something in the chat if you want. One of the reasons that we do this, one after another, next to each other, in a row, increasing by 1, yes, great answers, thank you. Some examples of consecutive, brilliant. Set of numbers coming next to each other, one after another, great. It's important in mathematics that we use terminology consistently. It's important in mathematics that we use terminology consistently. Definitions are important, and it's important that we agree on those. So in this problem, we have 5 numbers, A, B, C, D, and E. And we're told that they're consecutive. A natural way to encode this mathematically is to call them A plus 1, A plus 2, A plus 3, and A plus 4. That's a natural way to encode this information in the problem. And once I've got that, I can generate an equation. A squared plus A plus 1 squared plus A plus 2 squared is A plus 3 squared plus A plus 4 squared. That's a natural way to do this. Now, when you're solving a problem like this, as mathematicians, as we all are on this session tonight, it's really good to be thinking ahead, like you're a chess player, like you're driving, like many things where we can't just focus where we are right now. We need to be looking ahead. When I look at this equation, hopefully when you look at this equation, you might notice that it's a specific kind of equation. Can anybody give us a word that talks about this specific kind of equation? What is it? Yeah, quadratic. It's polynomial in general, but more specifically, it's quadratic. Yeah. And so we know how to solve quadratic equations. This is something we learned really well in grade 10 in Ontario, perhaps in a different year in a different province. And we're good at expanding these, simplifying, solving. I'm not going to do that part here because I know you can do it. I want to show you a second approach to encoding the information about consecutiveness. This is an approach that doesn't save us a lot of time on this problem, but might save us a lot of time on a different problem. And that is when you have an odd number of consecutive numbers, often encoding it so that the middle one is our base number somehow can be really helpful. So calling it C, C plus 1, C plus 2, C minus 1, and C minus 2. At a certain point, that's not really that different from what I just did. I'm just picking a different point of reference. And then again, I can square and add these like so, and use the equation that I'm given in the problem, substitute my variables, and I've gone from 5 variables down to 1. That's a win for us mathematically. When I've got an equation in 1 variable, I can often solve it. Here, again, I get a quadratic equation. One nice thing about this quadratic equation is that the constant term on the left side equals the constant term on the right side. I have a constant term of 5 on each side, which will cancel, making my quadratic a little bit easier to solve. Maybe not a lot easier. Maybe in this case, I'm not really saving much time, but this is an important kind of idea to know about. Using the middle as your reference point instead of one of the ends, sometimes helpful. If you follow this through, I think you get 10 squared plus 11 squared plus 12 squared equals 13 squared plus 14 squared. That's my answer. I would get c equals 12, I'd get a equals 10, and I get this as my solution. And I'll go back and check the question. I was asked for the value of a. So in this question, in this case, the value of a is 10. Interesting thing to think about. This is a little bit like something like 3 squared plus 4 squared equals 5 squared. I have 2 terms on the left, 1 on the right. Now in this new one, I've got 3 on the left, 2 on the right. I wonder if I can do it with 4 on the left, 3 on the right. 5 on the left, 4 on the right. What happens if I increase that? A little bit of investigation that you might want to try if this is something that intrigues you. One neat thing that can happen sometimes from mathematical problems is that we can say, hey, wait, if I change this, what happens? This is the fundamental part of research, whether it's in mathematics, computer science, or other disciplines. It's asking questions about questions. You know, what if I did this? What if I multiplied these numbers together in this way? What if I did this chemistry in a different order? What if I changed this beginning setup in a physical engineering problem? What happens? This is our curiosity as humans. If you find a question you're curious about, run with it. See what you can find. We'll answer one quick question that has come through in the Q&A, which is, do we need to know calculus? There is no calculus on the CSMC or the Euclid. Occasionally, there might be a problem where you can use calculus, but you don't ever need to do calculus. Will be marked incorrect or part incorrect if we use a different method? No. Our markers are really good at this. Correct mathematics is correct mathematics. We don't require you to pick a specific approach. We require you to pick a correct approach, and we'll mark that, and we'll read it carefully, and we'll digest it and figure this out. This question that I've just asked you here is, I think this was about an A3 when it was asked on a contest a couple of years ago. Let's move on to this next one. I know there are questions. I'll try to keep answering questions as we go along, but I want to be mindful of the time and not keeping you too late, particularly those of you who are east of Ontario, where it's starting to get a little bit later in the day. This problem involves notation which might be less familiar to some of you. It might be completely unfamiliar to lots of us. This is a notation that's defined in the problem. Mathematicians call this the floor function. We say the floor of x. That's what the words we use. This denotes the greatest integer which is less than or equal to a particular value of x. So for example, the floor of pi is 3. Pi is 3.1415 something. Some of you probably all know more digits of pi than I do. But so that means that the largest integer less than pi is 3. Less than or equal to pi is 3. So in this question, we're given a sum that has 100 terms. Let's just verify that. Let's just verify that that's the case. Well, let's look at the last terms here. I have a 1 over 100, a 2 over 100, a 3 over 100, all the way up to 99 over 100. That means there are going to be 99 terms there, plus the one at the beginning. So there are 100 terms there. We now want to try to figure out what the answer is. Each of these terms is going to be an integer. What's the total sum? Well, the first one's the floor of pi is 3. The next one is the floor of pi plus 1 over 100. That's like the floor of 3.15. That's still 3. We've got the floor of 3.16 is the next one, more or less. That's still 3. If I go to the end, I get the floor of pi plus 99 over 100. That's like the floor of 4.13. That's going to be equal to 4. So somewhere in the middle, we're going to switch somewhere in the middle from these being equal to 3 to being equal to 4. I'm going to have a bunch of 3s at the beginning and some 4s at the end. Our job is to try to figure out how many 4s there are and how many 3s. you know, maybe might note what I've just done here. I've subtly kind of changed the problem. I'm still asking the same question, but I've changed it in my mind. I know that these should all be 3s and 4s because the smallest one is 3 and the biggest one is 4, and they're all integers. How many 3s? How many 4s? This is a way of recasting the question to allow us to think about this in a different kind of way. I'll give you a bit of a hint that pi, if I look at the floor of pi plus 80 over 100, one that's kind of in the middle there, that's about the floor of 3.94, and that's still 3. Remember, I'm not rounding here. I'm not rounding, I'm going down always. So I'm going to leave this to you to figure out where this breakpoint is. Where do I switch from 3 to 4? How many on the 3 side? How many on the 4 side? Do you need to worry about knowing notation like this? If the notation is not familiar notation to you, we will tell you about it like we did here. We do our very best to try to make sure that you have the chance that if there's something that might not be familiar to everybody, that we provide that either in the question or sometimes as what's called a useful fact right before part A or right before part B. You might see a little box that's there. There's another curriculum question here. Do we need to know vectors? No. Advanced functions, I guess it depends what we mean by advanced functions. There's some functions, trigonometry, logarithms, exponentials are pretty common things that we will ask questions about. Some of these may be more familiar to you. Some of them may be less familiar to you. All right. If you want to put an answer in the chat, you're more than welcome to do that. And then you can have a chance to check it. But as with everything, I strongly encourage you to try the problems yourself. Okay, let's move on. And I want to talk about 2 more questions here. These are 2 more part A questions, and these are in the A4, A5, A6 range. These are questions that involve some technical things. These are that involve some technical skills. Mathematics has technical skills, and that's a really important part of mathematics, but it's not all of mathematics. There are lots of great questions that don't involve being really technical. Again, I want you to take a couple minutes, pick one of these problems to look at. Think about how you might start this, how you might get into one of these questions. Take a couple minutes, do that, and then I'll talk about each of these questions for a couple of minutes. Again, not solving the questions, but talking about how you might think about how to approach them. Okay, I'm going to stop talking, give you a couple minutes, and then we'll return to this. Before I dive into these questions, I'm going to address a couple of the questions that have come up in the chat here. Do we use trial and error to check if the floor of pi plus 80 over 100 is 3? I wouldn't call it trial and error. We need to think about what pi plus 80 over 100 is. It's 3.94 or thereabouts. And then we need to think about what the floor means. It means the greatest integer less than or equal to something. So if I've got 3.94, the integer, the closest integer underneath it is 3. Second question I'll answer here is CSMC harder than the AMC 10? The AMC 10 is a multiple choice contest. Obviously, they're very different. I don't think we can really easily compare the level of difficulties of them. Question about logarithms and content. This is an important question. I was having this conversation with somebody else today. Contests are not based on a specific curriculum. Because our contest is written by students from across Canada, like all of you who are here tonight, and around the world, we can't stick to a specific curriculum. So we don't follow necessarily the specific Ontario curriculum or a specific other curriculum. So it does mean that there will be some topics, no matter where you are, that maybe are things that you haven't quite gotten to at school yet. And that's okay, in my opinion, because that's part of the philosophy of the contest. And also knowing that there could be questions that do involve content that you've already done that are pretty hard and that we might not have time to answer. You might not have time to answer over the 2 hours. You might not have really a chance to get to them. So that's part of what this is. If you're in grade 11 or grade 12, we recognize that everybody's a different stage, and that's how the contests are constructed. So let's look at these two problems here, calling these problem 3 and problem 4. For the first one, we want to determine all of the values of x for which this equation is true. What I want to focus on in this problem is thinking about how I might want to get there. Often when you have questions like this involve exponentials, a really good strategy is to try to get to the situation where you have a power on each side of the equation, and then you can equate the exponents. If you can write this equation eventually as something like 2 to the something equals 2 to the something, then I can say that the exponents are equal, and then I get an equation in terms of x. With problems involving exponentials, that's often a good strategy. Not always the one that works, but often a good strategy that you could follow down. Of course, there could be problems, occasionally problems that involve logarithms. If logarithms are less familiar, have a look at the review packages that I put the link to earlier on, and you could see, you do some practice for that. Let's have a look just at a couple of the steps for this particular problem. I'm not going to solve it all the way through, but I want to show you how we might start it. I really encourage you, even though this was a part A question where you just had to give an answer, be careful as you go through and take the steps one by one. Be easy to skip some steps. I really encourage you not to do that. So I would start here, and there are different ways of doing this. I would start by changing the 4 to a 2 squared. I'm going to make sure I go back. 4 is 2 squared, and my exponent is x squared minus 3x. This is all squared, and the right side is 2 to the exponent x minus 1. So I've changed my 4 to 2 squared. Now, let's continue to use exponent laws. This is now 2 times 2 to the exponent 2x squared minus 6x. That's all squared, and it's equal to 2 to the exponent x minus 1. So you'll notice here, when I have a power to a power, then I multiply the exponents. That's what I've done. I multiplied the 2 from inside the brackets with the bigger exponent behind it. Now I've got a product of powers. I add the exponents. This is 2 to the 2x squared minus 6x plus 1, all squared. And that's 2 equals to 2 to the exponent x minus 1 still. Now, again, I've got a power to a power. This is going to give me 2 to the exponent 4x squared minus 12x plus 2. This is equal to 2 to the exponent x minus 1. Now I've got to the stage several steps along. I've got to the stage where I can get a quadratic equation. I can write out a quadratic equation and I can solve that now for x. Question that's come up a couple of times here is whether there's a formula booklet that's available in preparation. There isn't a specific formula booklet, no, that's available ahead of time. Review some of these concepts. These are all things that you will have learned at school or will be learning soon at school. Have a look at the resources on our site. If there's a formula that we think is less known to you, we will make sure we give that to you. So that's part of it. And there may be some things that are things, as some of you have suggested, that are less familiar to you because of where you are in the process of taking courses. That's completely fine. Try the contest, sit down and write it. There may be some questions that are less familiar. That's fine. Go on to the next question. Remember that just by writing it and trying it, this is the most important part. If you do well, even better. But just write, just sit down and try to solve some problems. I'm trying as we go through tonight to highlight some of the approaches that you might use as you're going along, and give that a chance. Again, don't get too stressed about a specific mark or knowing specific content. Use the knowledge you know, try some old questions. This will help set you up really well for success. I want to talk very briefly about problem 4 here. This is a problem that also involves technical things. It involves trigonometric functions, sines and cosines. All of a sudden, though, this problem here has some particular qualities to it. First of all, it's a system of equations. There are two variables, x and y. However, it's not like a system that we see most of the time, because the x's and the y's are tied up inside other functions, are tied up inside sines and cosines. The first equation has a sine x and a cos y. The second equation has a sine y and a cos x. That's kind of unusual. And it means that our standard approaches of elimination or substitution are probably not going to work quite so well here. So it may mean that we have to have a creative approach. I want to stop and just say something about that. Mathematics is a discipline that many people view as not creative at all. I would argue that mathematics is exceptionally creative. Mathematics is exceptionally creative because it involves taking material and using it maybe in different ways, in unexpected ways. And that's one, for me, one of the fascinating and sometimes frustrating, but fascinatingly frustrating or frustratingly fascinating things about mathematics and about problem solving. This kind of problem is one that some of us would stare at for a long time and say, I'm not really sure what to do. And some of us would immediately say, I have an idea, let me try that. I'm somebody who doesn't always see an approach right away. And I often see an approach after the fact. I often see an approach because if I'm off doing something else, all of a sudden my mind says, hey, wait, that problem that I was working on, here's how I might do it. This happened to me recently. I was trying to solve a problem and I got an answer that I knew wasn't right and I couldn't see what was going on. And I was out for a run early one morning and all of a sudden in the middle of the run, the answer came to me. So this is the kind of thing that can happen. If you don't get a question on the contest, don't stress about it. Try it later. Come back to it. Let's talk about this one here. What's the value of sine x plus y? Well, it's helpful to know that this is equal to sine x cos y plus cos x sine y. This is one of these formulas that we put on the contest because we know this is one that not everybody has gotten to yet in their curriculum. So we put this question, this formula, when this question appeared on a contest, this formula appeared as well, just so that you had a chance to do this if this formula was unfamiliar. Now, for me, looking at these two equations and looking at what I want, Often when we solve systems of equations, it's x and y we want, but here it's not x and y. It's something involving x and y, and maybe there's a way to get that without getting x and y first. After staring at this for a while, you might think of squaring this first equation. Why would you think of that? Well, if I think of this first term as a and the second term as b, a plus b all squared is a squared plus b squared plus 2ab. And all of a sudden, there is the sine x times cosine y when I multiply 2 times a times b. 2 times 3 sine x plus 4 cos y. That's 2 times sine x times 4 cos y, sorry. That's my 2ab, and there's that product of sine x and cos y. So if I square this equation and square the next equation and add them together, all of a sudden I'm going to have the right kinds of things. Could I use elimination to get rid of the cosine sign? You can, but you do need to be really careful because I've got a sine y and a cos y in different equations and a cos x and a sine x in different equations. There are some things that you can do, but they get pretty cumbersome pretty quickly. Multiplying them might be another idea to think about, except when I do that, I actually don't get any of the terms I want. If I multiplied the equations, I would have a sine x sine y and a sine x cos x, which aren't things I want. So these are great kinds of ideas, and these are exactly the same kinds of creative ideas. Yes, squaring the equations. This is what we want to do here. If you're not, some of us can see 4 algebraic steps ahead. Some of us really need to sit down and try this. So sit down and try, square both equations, and then add them. See what happens. Good things will happen here. This is a question where you don't really need to know anything. That's not fair. This is a question in which you don't need to know a lot of properties of sine x and cos x. You need to know a couple of things, and you'll see that as you go along. But it's also a question where you shouldn't be afraid to just try something. And this is, I think, a really important part of mathematics, is not being afraid to try something. To dive into this and say, I'm going to try this approach. Maybe it's not going to work. Maybe I have to try 3 approaches before I find the one that works. But trying is what leads us to finding out those things. For questions like this, whether it's exponents or logarithms, anything else, exact answers are always far better than decimal answers for approximate answers. Exact answers are always better. You may be somebody, as we've said a few times before, who's in grade 11 and taking functions right now. The CSMC is not going to be full of material that you haven't seen yet. There could possibly be some material you haven't seen yet for all of us, depending on where we are, and that's okay. The important thing, as I said before, is participating and trying. If you're in grade 11 and you're taking this now, brilliant. This is great practice. It's a great learning opportunity for you, and that's really important. There's a question in the chat about a technique called induction. Induction is a technique where we can use to prove statements, to prove sequences of statements. You can use induction if you want. There will not be questions that require the use of induction. That's something we're really careful about. But if you know induction, it could be useful. All right, let's keep going here. I want to move to problem number 6. We've talked so far about questions from part A. These are questions where these are standalone questions, one part worth 5 marks. I want to talk about a little bit from part B. I've only got about 10 minutes left. I know I'll probably go a few minutes over time, and I recognize that some of you will have to leave when we reach the bottom of the hour or the top of the hour if you're in Newfoundland, and that's okay. But we're going to keep going here. In part B, the questions have multiple parts. The total for each question is 10. This is an old B1. It had 4 parts. This is from a year or two. I think this is from last year, in fact, from the 2021 CSMC. I want to mention a couple things about this. First of all, these 4 parts, the marks add up to 10, and I can't remember, in fact, how they're distributed. 2s and 3s, various, and it will depend on the various questions and the difficulty, how much time it takes to answer them, those kinds of things. Let's look at this question. The various parts, let's look at the first couple of parts. Part A, factor x squared minus 4. This, for lots of us, is something that's not too hard. This is something that we have practice with. We're used to factoring differences of squares. Part B kind of looks a bit similar, but isn't totally similar. Part B, you could do this using a calculator. 98 squared minus 4, you could plug that into a calculator and get, I think, 9600, probably 9604 minus 4. You could do that, and that would work. But you could also notice that this on the left side is 98 squared minus 2 squared. 4 is 2 squared. So I have a difference of squares. And that suggests to me that there's a theme in this problem. Often the parts of a question in part B are connected to each other. Often there's a theme. It's, as Jane has just said in the chat, this is a difference of squares moment. Exactly. This is a difference of squares moment. All of the parts here seem to have to do with difference of squares, at least so far. If you are going through one of these problems and you get later on in the problem and you're not sure what to do, see if you can figure out what the theme was and try to apply that to the later questions. Let's have a look at part D. Part D is the one that seemingly doesn't look like a difference of squares. And this is what Feng Yang has asked in the chat. Is this also a difference of squares moment? Last year, when we were marking this, there were lots of students who did very well in parts A, B, and C. Then they got to part D and said, well, I'm going to check. 3, 999, 991, it's not divisible by 2. It's not divisible by 3. It's not divisible by 5. And they tried 7, 11, and so on, and didn't get there. But if you notice that this looked like a difference of squares, or tried to write it as a difference of squares, you might have had some success. To do that, you have to look for a square that's larger than 3, 999, 991. That will be the top square in the difference of squares. And probably recognize that we're not likely going to use a really obscure square there. And so if you look at 4 million, that's just a bit bigger than the number that I have. And I subtract 9, I get 3,999,991. This is 2,000 squared. This is 3 squared. And this is 3,999,991. Well, what am I trying to do? I'm trying to prove it's not a prime number. What does that mean? It means I'm trying to prove I can factor it. Can I factor it? It's a difference of squares. As Edwin and Ananth and others have pointed out in the chat, if I write this as a difference of squares, it's 2,000 plus 3 times 2,000 minus 3. That's the left side there. We tend not to use difference of squares too much on numbers. We tend to use it on algebra, but we can use it on numbers too. It's the same distribution principle. And now I've shown that this big number isn't prime. That's kind of a cool way to show that a number is not prime. That was part of the reason that this question got asked, so that you could make this kind of connection. Here's a neat way to show something. Without parts A, B, and C, if we had just asked you that, that's a hard problem. That's a hard problem to sit down and try to figure out what to do. But because you had 3 cracks at setting up a technique, all of a sudden we've, as Ryan said, we've learned something kind of cool here. A cool way of doing this. Will questions in part B always be connected like this? Often. Not always in this exactly the same way, but the same kind of thing. This is one of the differences between the Euclid and the CSMC. is that in the Euclid, most of the questions aren't arranged with parts that are connected. Is the CSMC equal in difficulty to the Euclid? It's probably about the same, I would say, but again, it depends a little bit on your approach, on how the questions line up for you. There could be a year where you do better on the CSMC than the Euclid, or vice versa. Let's keep going here. Let's have a look at the next question here. This problem 7 here, this is an old B2 from a few years ago. Again, there are connections between the parts. A couple of questions from the Q&A. Is the format kind of like the COMC? To tell you the truth, I'm not totally familiar with the format on the COMC, so I can't give you a good answer to that. You could look at the two and compare them. If you just said that the number can be factored this way, would you get full marks? You'd have to explain a little bit more than just giving that, but it's the same kind of approach. It's important that you don't have to necessarily tell us how you got to your answer, depending on the kind of question. Some questions you do have to show it, and some occasionally there's a way of doing it without showing that. But then it would have to demonstrate that your answer was actually correct. In this question here, which was an old B2, part A, we determine a positive integer x for which a quarter minus, yes, I did skip question 5, by the way. The last one was called question 6. I did skip question 5 in my slides. We want to determine a positive integer x for which this equation of fractions is true. This question is not too hard to do. Fractions, of course, cause some difficulties for some of us, but practicing fractions is really good. Parts C and D also involve equations that look kind of similar, except they have 2 variables in them in part C and kind of 3 variables in part D. These are similar, though, to the style of equation from part A. And then there's this part B thrown in the middle, which doesn't really look like parts C, D, or A at all. But maybe it has a connection. I want to talk very briefly about this. Part A, most of us can solve relatively quickly. Fractions can make our brains explode, yes, but let's keep working on them, keep practicing with fractions, and they will get there for us. In part B, well, let me talk about part C first of all. This is a B2, so the latter parts of B2 are going to be more challenging. Let's try clearing denominators. Let's try multiplying through to get rid of denominators. Sometimes in equations with fractions, this is a good idea. So if I multiply everything by y times z times 12, I get 12z minus 12y equals yz. 12z minus 12y equals yz. Now, it's not clear what I do with an equation like that. I'm going to rearrange it to look a little bit like the equation in B. I'm going to rearrange this and write this as yz minus 12z plus 12y equals 0. It's not at all clear what I should do with that equation. It's not at all clear what I should do with that equation. Let's go back and look at part B. Part B, the equation is written in kind of a funny way because I have a -1 on the left and a +4 on the right. There's a good chance that that's not just done by us to be annoying to you, to be honest. There's a good chance that's done to set something up. And if I look at the first 2 terms and take out a common factor of B, I get B times A minus 1 plus A minus 1 equals 4. And that means, looking now at a common factor of A minus 1, that A minus 1 times B plus 1 equals 4. Now I've turned a question that has an equation that looks very unfamiliar to us at the beginning into an equation where I'm multiplying two integers and getting 4. Multiplying two integers to get 4, there are not that many ways to do it. So by doing this factoring here, I get to a situation where I have an equation that I can solve by looking at 1 and 4, 2 and 2, 4 and 1. Maybe negative integers too, but probably not because A and B are positive. You have to think through that. This equation here in part C looks a little bit like the equation that I started with in part B. So can you somehow get this equation to a stage where you can factor it like the one in B? I'm not going to tell you how. I'll let you think about that. You need to add something to both sides of the equation or subtract something from both sides of the equation. At least that's one way to think about this. Once you've done that, maybe you can factor it. Maybe you can then start to find some solutions to it. So think about that. There's another, Patrick has suggested in the chat, another way of doing this. I thought to write solve for Z in terms of something else. Great. Philip suggests Python as an approach. Well, Python works well if you're not sitting down writing a contest, but a good way of solving a problem like this, as long as you have a specific range of problems. Python is a programming language for those of you who don't know it. You can't use a programming language in a contest, but you can try it when you're fiddling around with problems like this. I want to mention question B3 very, very briefly, and then I'm going to I want to talk about B3, and then I'll throw things back to Laura Jane to wrap up, and we'll keep answering questions as we need to. Here is this is problem 8. This was an old B3 from a number of years ago. This is a problem that involves counting. Like many B3s, it starts with a preamble, a bunch of text where you have to read something and understand what's going on. We define the idea of a string of length n, a sequence of characters, and what a substring is, a substring being a block from inside a sequence. I've listed part A and part B here on the screen. There was a part C as well. I just want to talk about part A. We want to list all strings of length 4 with characters from the set A, B, C. So they're length 4. That means there are four letters in it. And I want both the strings A, B, and BA to occur. So we could have strings that have an ABA in it, and maybe something on the beginning or the end. We could also have a BAB, maybe something on the beginning or the end. We could have ABBA, where the A and the AB and the BA don't overlap. They're separate. We could also have something like, excuse me. We could also have something like BAAB. Thank you for the help in the chat with my sneezing. I appreciate that greatly. We'd also have a string where the BA and the AB are separate from each other and not together. So in this problem, this problem demonstrates something really important about mathematics. It's having to do things carefully and systematically and sequentially. This, at the end of the day, is one of the most important things that mathematics teaches us, is that kind of thinking. So while we could all try to understand the question here, which I think we can if we take a few minutes to read it, you could then start to write out some strings that work. The trick is trying to write the strings out in a way that makes sense and helps you make sure that you've got everything. This is a super important part of mathematics. It's teaching that logical thinking, learning that logical thinking. If you can do that here, set this up in such a way as you can write it out nicely, and be sure as you're going on that you've got everything, then this is the key to a problem like this. It's not hard to do. Question 3A, question 3B and C will be hard. I encourage you all to try 3B and 3C. But make sure for sure that you try 3A. 3A is not going to be easy, but it will be accessible. It will be a question that you can try and you can make some progress on. So make sure you take some time to read question 3. Even read it near the beginning. Your brain will think about it while you don't think your brain's thinking about it, and may have some ideas by the time you come back to it. Problem solving as a part of mathematics is vital. We as a world, as a society, we need people who can solve problems. We can all look around our world today and see lots of problems that need solving. So it's really important that you, as young people, as future leaders, take some time to practice solving problems. If you practice solving problems, and regardless of whether you go into mathematics or computer science or another STEM discipline or not, the approaches that you'll learn in mathematics, logical thinking, systematic thinking, communication, this is a big part of mathematics, explaining how you got an answer. Creative thinking, also a big part of mathematics. These are skills that employers want. These are skills that the world wants. Not everybody finds writing a contest the most exciting thing that they can ever do, and that's completely fine. Take some time, though, even if you're not writing the CSMC, try some of these problems. If you don't have somebody in your school who's also writing this with you, find a way of trying them on yourself. Find a way of following through the modules that we have on our website. Work through some of these. Talk to one of your teachers for some advice from time to time. Working through mathematics is a great way to get better at mathematics. I encourage you to all think about doing that, and I wish you all the best of luck in a couple of weeks, those of you writing the CSMC. And we hope that our paths will cross again in the future, whether it's in one of our programs or another thing. And by being here, by taking the chance to come on a Thursday evening to do some mathematics like this, by thinking about these mathematics, you are demonstrating that you're committed to your education. And that's really, really, really commendable. So thanks for being here tonight. I'm going to throw things back to Laura Jane in mathematical headquarters, wherever she is, and we can continue to answer a few questions here and there. Laura Jane, back to you.
Thank you. And thank you so much, everyone, for your keen participation this evening. A huge thank you to Ian for presenting another incredible workshop for our math-loving prospective students. A quick note that this weekend, Saturday, November 5th, the University of Waterloo is running our first fall open house in some years. We hope that those who are able to travel to our campus might consider dropping by. There you'll have an opportunity to speak with faculty, staff, and students of the Faculty of Mathematics. As Ian mentioned, our admissions and outreach team will stay in the Q&A for a few minutes should you have any questions for us. And thank you again, Ian, for your time tonight. Wishing everyone a great day.